continue the conversation. There's a link on the Meetup agenda, but you can also get it off the website. And you can always check out learn.neurotechx.edu for lessons and more information. And sign up for the newsletter and check out the job board for posting or for hunting. All right. So,
what's your favorite neurotechnology, Morgan?
What favorite neurotechnology?
Your favorite.
Oh,
I have a guess what it's going to be.
I mean, yeah, honestly, it's EEG.
There's going to be like 256 channel EEG.
Well, okay, well, okay, ultra high density, maybe.
Written it down on a piece of paper here.
But I still think that EEG is an untapped resource. Coupled with your kinds of computational neuroscience simulations. But anyway, I am looking forward to talking about NERS, and been enjoying some of the discussion on Slack with regard to that. Actually, somebody on Discord was asking about hyperscanning with FNERS, and they just got 3 NeurotechX systems. Like, damn, okay. Very interesting stuff. So, but today, well, following tradition, I just want to say if there's anybody who's here for the first time, now's the usual time. We ask you to just introduce yourself and tell us a little bit about what you're interested in.
Hi, I'm Poe. I'm new here. I'm actually from Australia.
What time is it there?
It is 11 a.m., so it's perfect.
Okay. Okay, awesome.
Yeah. So I'm second year undergrad, so pretty new. My interests are I just want to know more about it because I recently just coded a very small brain computer face controller, and seeing the work in Melbourne that is being done on rehabilitation really excites me. So I just want to prod around.
Is that where you're based? Is it Melbourne?
Yeah, I'm based in Melbourne.
Cool. That's awesome.
Good stuff in Melbourne.
Is that like a stroke rehabilitation or?
Any rehabilitation, I think, is awesome. But okay, so that's a good question. So mostly musculoskeletal, so paraplegics.
Okay.
Yeah, that kind of stuff.
Sure. And I'm guessing you caught the recent Neurotech X Australia meetup.
Yes.
Great.
Yeah. I work closely with Farhad and
okay, awesome.
Yeah, they're awesome.
That was great. International set of speakers. Christoph joining us at like 3 a.m.
Oh yeah, that's crazy.
Which is also where we got the first glimpse of the 1024 system. Anyway, it was the first glimpse I got.
Nuts.
Yeah. Well, thanks for introducing yourself, and I'm glad we can pick up Australia at a decent time.
Me too.
For our evening, and so yeah, if you want to come back and tell us more, give us more details about projects there, I'd love that.
Yeah, East Coast is taking the hit on the time zones on this occasion. Normally it's Australia, but not this time.
So, and on that note, let's move over to Brian. We'll get more introductions in later, but let's move over to Brian. Since Brian and Arvind are joining us from the East Coast. Brian, well, I don't think you really need an introduction. Connectome manager for Neurotech X, and also grad student in a EEG lab. I mean, it's EEG plus, no?
I guess we could qualify it as EEG for rats. We do LFPs and single unit, and we actually just got a fiber photometry setup, so we're going to be building that out soon.
Okay, well, which is what I'm hoping we'll talk more about with some of the people from Boston. that are experts in that. But great. So yeah, Brian, I'm going to turn it over to you to give us just a rundown of the recent town hall.
Great, thank you. I appreciate that, Morgan. I'm happy to be here. Now just bear with me as I figure out the screen sharing and moving.
Oh yeah, it's the middle button down on the left. Oh, bottom left, sorry.
Yeah, I got that there. I'm going to share it and just give me a thumbs up or something if everyone can see it.
Yes.
Fantastic. And you can still see it? Big splash screen with the Neurotech X logo?
Yes, sir.
Wonderful. Awesome. Okay. Fantastic. Thanks very much, Morgan, for the opportunity to speak to everyone today. And thanks to anyone involved or joining for the first time, or for those who kind of continued their attendance at the San Francisco Hack Nights. It's a true pleasure to be able to present some of the awesome stuff that we're doing with Neurotech X to you today. So before I get started, I'm just going to mention that I'm okay with you interrupting me for questions, so please feel free to just ask them as they come up. If you would like to talk a little more in detail about some of the things presented today, you can also email me directly, and that's at Brian, B-R-Y-A-N, @neurotechx.com. And you can also reach out to me on Slack, and I'll be able to reply that way as well. So with that, we will start off with a kind of reflection on how Neurotech X began as a community and ultimately what we're working toward. And as Morgan highlighted, this is a kind of high-level overview of the town hall that we recently completed on August 29th. So this section, the past, present, and future, was presented by our co-founder and executive director, Yannick Roy. And so I'll try to do my best at filling those shoes. So 5 years ago, in 2015, Neurotech X started with the mission to facilitate and accelerate the development of neurotechnology. And now this is a broad mission by design. We're growing a global community, which will touch on many sectors, disciplines, and whatnot. And so we designed it to be very broad to get a full 360 kind of impact on that neurotechnology sphere. We saw a lot of growth in the early years. San Francisco is certainly one of those chapters that started there early. Toronto as well. We have a few folks on the call from Toronto, and they can understand the experience that we had where we saw a lot of early growth, which to us indicated that there was a demand and a need for this kind of community of enthusiasts to really work together on some cool neurotechnology projects. But then we also went through a period of pruning, or kind of refocusing and refining our initiatives, our approach, our processes, towards a goal of a kind of stable longevity with the Neurotech X community and brand. And so now I'm happy to say that we're at the point where we're kind of revamping, or have revamped, most of our initiatives, and we are recharged, and we're now building lasting momentum. So it's a really exciting time to be a part of the community. You'll see through this talk that there are many initiatives that you can join and get your hands on and ultimately kind of lead, if you will. So my personal journey with Neurotech X began in 2015 when I co-founded the Neurotech Toronto chapter, and over 2 years grew that up to a large community. We ran 20 plus events. It was a lot of fun. And from there, I kind of took a role where we were practicing or piloting a model for kind of inter-chapter connectivity, again, towards this idea of really creating longevity with the community. And now I'm in the role as Connecto Manager, as Morgan alluded to, where I'm overseeing the chapters initiative. So I get to work with the wonderful people around the world, building their local communities and creating awesome content globally as well. So what we're working toward is somewhat depicted by this graphic. I'll note now that it's a work in progress. It's by no means complete per se, but it's kind of a nice representation of our experience so far and our testimonials of individuals in the community who have experienced this, where, as you'll see on the left, we kind of have people joining from different backgrounds, different stages of their career, be it early entry-level enthusiasts or kind of experts with 20 plus years of experience in this area. And we funnel them through to our pillars, as Morgan highlighted, the community pillar, education pillar, and innovation pillar. And through this, they can develop, they can learn, they grow with the community, and they ultimately land in their dream neurotechnology experience. This could be joining a neurotechnology company, starting a company. They can be inspired to continue or to create research, to get involved in other related neurotechnology initiatives, or of course just kind of tackle their own perceived challenges within neurotechnology. And importantly here, it also creates this opportunity for feedback, where we have individuals who have been trained through this funnel, ultimately then hopefully inspiring other individuals to embark on a similar path that they've experienced. And I'll mention now, because I'm not going to expand on it later, that we do have a fair number of testimonials that can kind of highlight this experience. I certainly can speak to my own experience working with Neurotech X, and I would encourage everyone to just keep their eyes peeled for our 5-year anniversary campaign that should be coming up very soon, where we do hope to highlight many of the voices within the community that have really made all of these initiatives so successful so far. So breaking this down a little further, at Neurotech X, we bring neurotechnology enthusiasts and experts together. We provide kind of the resources, the support, the network, the direction to create ultimately an inclusive and collaborative ecosystem that we've depicted here in this graphic. So although we do have like this director and officers level, it is a bottom-up initiative. And so really those roles are support roles for the many initiatives we have across our pillars: community, education, and professional development or innovation. And then, of course, we have our support initiatives that kind of support across these 3 pillars. So I will not be able to touch on all of the initiatives today, and there's just many things, amazing things happening in the community. And so I will encourage anyone watching now to subscribe to our Neurotech X YouTube channel, as we will be releasing the town hall publicly for people to watch and to find out all the other amazing things that are happening. I'm going to touch on our diversity committee, the chapters initiative, of course, Neurotech X services, Neurotech EDU, as well as our upcoming book and the newly minted Neurotech X content laboratory. So starting with the diversity committee, this is being spearheaded by Abigail Holland, who presented, of course, this content in our town hall, and also Maria Marano, who both of them actually have had really interesting paths within Neurotech X. Abigail started as a lead for the student club at Queen's University here in Kingston, Ontario, Canada, and then joined the, actually really spearheaded the development of the diversity committee and has been involved in numerous other projects within Neurotech X. And Maria joined as a community member in Toronto for Neurotech TL before she took a lead role with the chapter and ultimately led the chapter for, I think, over a year, maybe 2 years even, before ultimately moving on to other initiatives, namely the book that she's been instrumental in, and of course now leading our diversity committee. So importantly, this is a new initiative. It's a top priority initiative, and there's a lot of room to get involved. So as the slide says, they're still hiring. They're looking for individuals to be a part of their committee and their consortium, which I'll explain both of those in a second. Their focus right now is to improve linguistic diversity in the Neurotech X community. So they would like to see representation of all native languages. We can create content that doesn't require you have an understanding of the English language to be able to learn and to utilize. Demographic diversity is looking at creating equality within our community and the opportunities that exist within our community and for our community, and domain diversity as well. So really touching on those walks of life, or those expertise, those backgrounds, for example, invasive neurotechnologies that we don't necessarily have complete representation from yet. And so, as mentioned, they are really working toward the step 1 of building a very strong team. So there's an open call right now. If you're interested, you can find out information on our Slack by joining the #diversity channel, or by reaching out to Abigail Holland, whose email is on the bottom of the slide there. And because they are looking to find individuals for their committee, individuals who can kind of actively contribute to shaping this committee and shaping the initiatives that surround these priority areas for them. And they're also looking for members to join this consortium level of contribution, where you're ultimately going to be kind of steering the committee in their efforts within the Neurotech X community. So next is the Neurotech X chapters. And of course, this was presented by myself at the town hall, and everyone I think here is intimately familiar with the chapter initiative, considering that we are being hosted by the wonderful San Francisco for their regular hack nights. And so just a brief overview, this graphic kind of touches on where we are currently. So we have many chapters across the world and many more in the works, in the books. So this is a very nice kind of high-level snapshot of our spread, our reach. Importantly, we're all enthusiasts. We're all volunteers that are kind of just driven by the goal and the mission of impacting communities positively through neurotechnology, advancement and awareness. I'd also just like to highlight briefly that we have recently launched 10 new chapters within this year. And notably, we have our Neurotech X Australia group, as was mentioned previously, and they did a fantastic job with their launch event. We also have a lot of activity in India right now, but many more chapters to come. So we're happy to have these individuals in our fold, these teams in our fold. You know, we wouldn't be anything without the individuals who are kind of driving this forward beyond the chapter leads. And so we have our Connectome committee, which was also recently established. Jean joined us not even a month ago and has kind of jumped right in already. If anybody is a chapter lead here on the call or watching this, you'll have received some emails from her, no doubt. And we have Mohit as well, who I think is a regular at these hack nights, and he is, as far as I understand it, going to be speaking about his experience at the IEEE Brain Summer School next week. He's working with us for just shy of a year, and he's also kind of instrumental in leading our Buzz and Review and flagship event series, which I'll touch on in a second. So, kind of big. This slide here is really just a snapshot representation of all the incredible engagement opportunities that we've created over the years. Some recent, some definitely some throwbacks. I'm not going to go through each photo and touch on what they mean specifically, because I could spend hours and days talking about all of the fun stuff that we've done. But importantly, we've run many events, and we're definitely getting to the point now where we can create these kind of turnkey engagement opportunities where if a new chapter is started or if somebody's looking to do something in their locale, we have the resources, the experience, and the talent to pull it off. And so I will encourage anyone watching this to check out our website, Google Neurotech X and your city, and see if there's a local chapter for you. And if not, reach out if you're interested in starting something or talking further about what that looks like. I'm happy to have a chat. Okay, so briefly, the flagship event series for the chapter initiative is our Buzz in Review. And essentially this event happens once every year. This year in 2020, January 2020 was the first year for this event series, and it will happen again in January 2021. And it is a kind of lecture style event for most, where we cover all of the latest and greatest news from the preceding year in neurotechnology. So in 2020, January, we presented all of the news from 2019 across 8 chapters. We're hopefully going to be around 15 chapters in January 2021. So again, check your local chapter, see if we should be announcing them in the next couple of months. And so make sure to join. It's a fantastic opportunity to get kind of like a shotgun overview of all of the awesome news that happened in the past year, and ultimately a great opportunity for you to meet like-minded enthusiasts. Okay, so I'm going to touch on Neurotech X services now. This was presented by Adam Seffler during our town hall, who is the co-founder and president of Neurotech X services, along with Yannick Roy, who helped co-found the organization, and Radhika, who is the business development head, and Jose, who is the manager of our fantastic job board. This is the headhunting and consulting agency of Neurotech X. So it is associated with, but a distinct entity, and it's born out of the fantastically diverse and talented community that we have. There are many things that Neurotech X Services does. Right now, as mentioned, we have our awesome job board. So if you're looking for a job, definitely check it out. It's 100% neurotechnology, and there are some really cool positions on that job board. We also do visibility packages. If you're a company looking to get some visibility, we will be happy to promote you across all of our channels. And they're super affordable packages, very flexible packages, and we're happy to work with you to make sure that there's that kind of mutual benefit. And finally, there's some headhunting. This is really, again, leveraging the talent of our community. These individuals have strong networks. And so importantly here, if you have a friend, let's say, or a colleague who you think might be a great fit for a job that is being advertised through Neurotech X Services, you can refer this candidate to be interviewed. And ultimately, if they are provided a contract or they get the job, then you can be eligible for a referral bounty. So this creates this really interesting mechanism where we're ultimately inspiring this talented community to share colleagues, share opportunities, and then of course we also leverage that talent to be the headhunting service or the headhunting recruiters. I personally have dabbled in this a little bit. It's not my forte per se, and that I haven't done this previously, but it's a lot of fun. It's really interesting to see all of the talented people that exist out there in neurotechnology and related disciplines. So if you're interested in getting involved, you can reach out to jobs@neurotechx.com. I think you can also reach out to services@neurotechx.com, and all the information is on neurotechxservices.com. So it should be but a quick Google search away. Okay, for the next few slides, I'm just going to go over them very briefly because there's a lot that they do on the consulting side of things, and I could talk again at length about that. So I will just highlight this briefly, and if you want any more info, check out their website. Basically, they're working toward becoming a 360-degree perspective or entity. So they touch on, of course, science and research, technical and engineering consulting, both in the development of hardware and software. And I also mentioned that they do have cases where they've consulted on each of these categories, if you will. So there's good examples of the success for these efforts or endeavors. A lot of strategy and finance consulting, that's certainly Adam's and Radica's background, and so they're very well versed in this world. And legal, regulatory affairs, the tactical kind of organizational management, operational management for startups and large-scale organizations, and ultimately some stakeholder management or partner identification as well. So again,
Brian,
I would
your audio's a little going in and out.
I'm sorry, is it cutting out completely? It might be
no, but it's sometimes getting super loud, like big hum in the background.
Ooh.
Just I don't know if, yeah.
Yeah, I'm sorry about that. Usually with these headphones, it's pretty good.
Okay.
I fail to have a solution for that as well. I'll try and speak like consistently loud.
We can hear you. We can hear you.
Okay. Okay, great. Thank you, Morgan. I appreciate that. I also can't see you right now, so I'm kind of flying blind here. Okay, so yeah, sorry, to bring this back. Basically, all of these efforts, the work that the Neurotech X service is doing is to take them toward their positioning as the #1 source of opportunities for our community members, the #1 talent provider for companies in neurotechnology looking for neurotechnology talent, and of course the #1 consulting firm in neurotechnology. Now, leaving services and heading back into kind of the community realm, we're going to talk about Neurotech X EDU. And this has had a very interesting arc, and this was presented by Yannick Roy during the town hall. They started out by creating some incredibly awesome educational material, some really engaging platform or educational resources. I think a few of the individuals on this call are intimately familiar with these resources, these materials, but this was all part of their kind of 1.0 strategy, and ultimately a lot of really cool things are born out of it, but it's still fragmented. It's not cohesive across the different resources. And so with their 2.0 revamp, they're looking to create a kind of open education platform. Again, 100% neurotechnology, so really can cater to someone who's interested in neurotechnology, who's kind of that enthusiast, but hasn't really had the experience yet. So they can join the community, initiate that funnel, get all the information that they need to learn to grow and really become that neurotechnology expert. And so I think actually Morgan is involved in kind of spearheading this, and maybe I will be able to speak at length about where this platform is going currently and what opportunities exist to get involved. But I do know that they are kind of building a committee and ultimately people to hop on board. So I'll maybe let Morgan shout out how to get involved and help that further after this, if it doesn't come up already. Okay, the Neurotech X book is a really interesting initiative, and it's called the Neurotech Primer, A Beginner's Guide to Everything Neurotechnology, and this is presented by Lucas Shannon, who actually joined Neurotech X through the Montreal chapter, one of the founding chapters, as a community member, and then kind of jumped into many different initiatives, as most do. He's now a lead for Montreal, as well as leading this initiative to publish this book. And so they're looking to target a diverse audience, of course, kind of beginners, hobbyists, but neurotechnology enthusiasts and college students, so people who are still kind of entry level but have an awareness of it. And it covers many different domains, different topics, including neuroimaging, neurostim, ethics, etc. They will be releasing it hopefully this year, so stay tuned on all the Neurotech X socials, the Slack and whatnot for when that will be released, and grab your copy. Okay, last but certainly not least is the Neurotech X Content Laboratory. Again, this is a newly minted initiative led by Florencia, who's also leading our newsletter, which we didn't talk about today, and Adam Molnar from Neurable, and Ssvp Bci from our London chapter. And they are creating content, is the short delivery there. They are looking to create content across many different channels, but they're still very new, so they're building their team again right now. And so if you're interested in content creation, please reach out to any one of the three through Slack or email, and I'm happy to put you in touch as well with them. They are ultimately hopefully going to kind of string together many of these initiatives, so maybe even more supporting than anything, so that they can create content for our communities, for the educational platform, and ultimately for a lot of the professional development modules that we are working on. So stay tuned for that. I'm sure there'll be many more announcements related to that. And ultimately, there's a call for applications on Slack. So if you're interested, you can easily find it there. But as I said, email all of us, reach out to all of us. We're happy to hear from you.
Brian, I have a question.
Yeah.
So the content laboratory, can you elaborate a little bit more on that and how that differentiates from, the education stuff? And I don't quite get what it sounds quite generic, but maybe, yeah. So maybe could you kind of elaborate a little bit more? What kind of content are they amassing, or is it the amassing of all kinds of content is the idea there?
So it's both. Yes, the idea is to be able to create all kinds of content, importantly, so that they will kind of seed the initiative needs. So we have a fantastic newsletter. I'll encourage everyone watching now to join it, as Martin had done previously. And we get a lot of content for each of those newsletters. So part of their role would be to take that on and create the content for the newsletter. But also we're exploring options right now, kind of more immediately, to create a more engaging YouTube content, podcasts as well as something that we're exploring with a couple partner groups. And under this is also the blog, which is something that we started a while back, as well as webinars actually. So maybe another form of content like the blog. And so that would kind of encompass all of that. But the moonshot here really, or the long-term vision, is that this will be the lab that creates the content that supports all of the initiatives. Yeah. Hopefully that answers the question, John?
Yeah, that's helpful. Thanks.
Awesome. Thank you. Cool. Okay, so I'll end it there. I know I'm a bit over time. I'll just say, please do keep in touch. We're a community first and foremost, and we just love to talk about all things neurotechnology. So you can find us at neurotechx.com. You can email us at info@neurotechx.com. Best suggestion is to just hop into the Slack, introduce yourself, and away you go.
Yeah, thanks so much, Brian.
Great, thank you.
So I know, one of my follow-up questions I gave you earlier, which is when would we be able to find out about things like access to the WordPress site and, these kinds of chapter customization things, and potentially more infrastructure things as well.
Yeah, so I didn't cover the website revamp today in the presentation. There will be content presented in the video, or the version that we put up on YouTube, because we did have Zarna from our website revamp talk to that. But I did connect with Zarna today about a timeline, and I didn't get a specific date. I'll let you down there first. But it's one of the top priorities. They're finishing up their first phase, which was to get the kind of main landing page completed and functional, because there were a lot of issues with the carousel, and there were just behind the scenes, the code was kind of a nightmare, and so they were cleaning up a lot of it and just making it
is it like a full refactor?
Sorry?
I mean, is it like a full migration to a new?
Not a migration in the sense that they're migrating to a new platform or anything, but there was a lot of, I think, redundancy and just kind of errors introduced early that were built upon, and so they were doing a wholesale cleanup on the back end as well. Rufy from Paris was kind of primarily leading that. But I know that they finished the homepage and the Teams page, and or they're close to finishing the Teams page. Importantly, we want to have a kind of a class graduation aesthetic on the team page, where you see everybody involved in all of the different things happening in Neurotech X.
Okay.
And then the next phase will be to move into chapters and get those pages developed. Now, I don't know how long it will take. If it's anything like the home page and the teams page, there could be a lot of things to work throughout the back end to get it functional in a way that we could have multiple admins accessing it. But it's going to be top priority next for sure. And importantly, something that Zarna highlighted was starting to collect feedback now from anyone who's interested in utilizing the web page and accessing the web page to understand what accesses you should have, what we can do now to kind of set it up for the use then.
Gotcha. And I guess the only other question that we've certainly talked about here before is, are we going to get paid Slack, or what are we going to do about our 10,000 message limit? If because I think we're riding on a certain Slack moratorium, or dispensation, right?
Yeah, it's a ticking time bomb, this Slack thing.
Oh, yeah.
There's also, now that we have the Discord, that's kind of starting up, and people have already hosted their own little chapter meetings in there every once in a while, I've seen. Cool. But it still needs a lot more work to be at all comparable to the Slack. And then transferring people, that's another big issue, is I'm part of a group that has a very active Slack, a very active Discord, and 2 very active websites, a wiki and a custom forum system, and using all 4 of those is quite a mess. So how will the website try to be focused only on having the main content drivers and chapter leads be updating the website, or will each chapter have a media specialist type position?
Yeah, so ultimately it'll come out through discussions with the chapters, whether or not that's something that they would like to pursue. I think that kind of less management of information is better, to really focus on what's important. So my opinion would be to have the website for the chapter stuff be a little more kind of automatic or integrated with some of the other platforms we use, and ultimately low bandwidth to manage. So as far as I understand it, for the chapter page right now, it's going to be representing the leads working in the chapters, their kind of latest event. Hopefully we can integrate that with Meetup or Eventbrite or something, so there's no real need to constantly update that. And then your brief description, maybe a couple of projects that you're working on, you can link to different GitHubs and stuff. But beyond that, it's not going to be the primary resource for engaging with the chapter. That's going to be, Meetup for events, or Eventbrite if some of the chapters choose to go down that road, and ultimately Slack or Discord as we solve that problem as well will be the mainstay as well. To come back to that point, though, it's something that we constantly grapple with. I know anyone in the community really is probably aware of the limit with Slack, and also that we've been using the trial version of the Pro or premium version of Slack, and it's been wonderful recently. And so now that we've tasted the gold, it's going to be harder to go back. So I think
I was able to actually find some really old messages now. Anyway.
Yeah, and as I said, I'm used to it now personally. There's a lot of fun features that I didn't even realize.
How they stuck in. That's how they stuck in. Yeah,
100%. So I think, there are 2 sides. We could ultimately work to get paying funds for paying for the premium version of it, but I think it's better to just explore the benefits of Discord. And I'm happy that that community has already been created, because now the ball's already rolling. And so it's really just about the follow through now. The migration will be the trickiest part, but it will happen with time. And again, Slack, the Neurotech X Slack community wasn't built in a day, and it's going to take years as well, I think, to get it back to a comparable level with Discord and Slack, but we'll get there for sure. And importantly, we'll just listen to what everybody wants. And Discord seems to be the way right now, so it'll happen.
Okay. Well, hey, thanks so much, Brian. I mean, part of this was also just to get our feedback to you, but I really wanted everybody to get a chance to see how much great stuff, and we should share that the group photo more. I haven't put it on on the meetup, but yeah, that was quite awesome though, to just see the worldwide community there.
Yeah, no, it was really special. Thanks, Morgan, again for the opportunity to present some of the content. And I'll just end by saying, I guess, two things. One, check it out on YouTube, because there was a lot of kind of golden eggs in there that I didn't get to highlight. And B, I guess, apologies for my background. I just realized I got boxes and stuff in here, but I just moved, so it's been
Sure. Yeah, awesome. Thanks so much. And yeah, okay. Well, so if you do have more feedback, let us know, especially on Slack, and well, or on Discord. And I want to keep us moving. We'll save EEG notebook updates for later. We'll just want to introduce Arvind. And
yes,
yeah, so Arvind chimed in on Slack and the Moab channel and was talking about his master's work, and it seemed absolutely relevant to some other Neurotech X people who were really eager to bring steady state Veeps into to make Moab a platform that or a benchmark that includes multiple Ssvep data sets, and of course even better is to also have some state-of-the-art pipelines to benchmark against. Arvind, you did your master's University of Waterloo, and
yes,
currently an engineer at Interaxon.
Yeah.
What can I ask what you're working on?
Okay, so I'm a biosignal research engineer, and so we're working on really exciting projects. Yeah.
No details. No worries, but
yeah, and it's really great, and thank you for the opportunity. So actually, my background is in ECE.
Please.
My background is in ECE from India, and so during my fourth year of undergrad, we actually had the opportunity to work on brain-computer interfaces as our final year project, and so that's how I really got into BCI. And we had this open BCI board. One of our professors had the open BCI board, and so that's how we started exploring alpha-based, eyes open, eyes closed BCI, and then Ssvp. And then I had the opportunity to move to Canada and join the master's program at University of Waterloo, and so that's how I started working on Ssvp Bci, and so looking at different detection algorithms and improving the performance of Ssvp Bci. Yeah, and so I graduated last year, and since October of last year, I've been working at Interaxon. So yeah.
Great. And so, I mean, just in terms of your experience, so you've used OpenBCI.
Yes.
and now obviously Muse.
Yes.
Have you, I mean, I forget the public data set that you used in as at least in your paper. Do you remember what system that was from?
I'm not sure.
Was that from the Schwartz Center? Was that from
Yes.
the EEG lab guy? Okay.
Yeah.
So it's a biosemi system.
Yeah, biosemi, I think so. Yeah.
Yeah. And I think they usually only use a 64 channel
Yes.
system.
Yeah, that's correct. And even at the lab at University of Waterloo, we have this 32 channel. I think it's a GTEC GUSB amp.
Yeah, sure.
And so we use the wet electrode system there. But
Gotcha.
so for the research, we used that. We also had an open BCI with the new dry electrode, the spike based dry electrodes.
Yeah.
So I also had the opportunity to like work with that as a side project. Like I had this kind of real-time Ssvp kind of using OpenBCI with OpenVibe, and then
Okay.
just building like a real-time Ssvp system there.
That's cool. I'm hoping to get some of the OpenVibe developers to come talk about their. I know they got a new developer, so it had been kind of stagnant for a while.
Yeah.
I don't know if we'll be able to get Yan to, Yan's at Apple now.
Okay.
don't know if, how much he talks about OpenVibe, but that's great. And you're in terms of analysis pipelines, you're doing everything in Python, or
yes.
certainly.
So during my master's, we mostly worked in MATLAB.
Okay.
And so I was thinking that maybe a lot of people would find it useful when we have equivalent Python code. So that really like motivated me to move some of the code, like very small portion of that, to Python. And so I made that available on GitHub.
Yeah. And well, I'm gonna, you're gonna tell us all about it, but for everybody, you can find the links. There's links to Arvind's GitHub, as well as paper, as well as I think to your master's, depending on how much you want to read. And so you've got a presentation for us?
Yes. Yeah.
Sure. So you can take over. Okay.
So I'll be sharing my screen.
Yeah, and sorry, everybody's kind of new to Jitsi. So yeah, sometimes you have to also select your. Yeah, there you go.
Not. Is it visible now?
Totally. Yeah.
Oh, okay, perfect. Okay, thank you. Yeah, so this is basically a condensed version of the thesis work. So let's see how much I'll be able to like cover it. But yeah, it's kind of looking at like a big picture of the different experiments that we did as part of the master's thesis, and looking at some of the results. So the title of the thesis is actually Enhancing the Decoding Robustness of Steady-State Visual Evoked Potential-Based Brain-Computer Interface, which is Ssvp Bci. And I think there are a mix of people in the audience, like people who have some background in BCI and people who are kind of new. So I'll try to go like give an introduction and then go into some of the details. So yeah, this is basically the overview. There's an introduction. I'll briefly mention the abstract of the thesis, some methods, talking about some algorithms, and then the results and the conclusions from the project. So as we know, a brain-computer interface is a direct communication pathway between a brain and an external artificial device. And based on the features extracted from the neuronal activity of the brain, we could deduce some of the intentions, for example, like movement-based intentions, or have some kind of external stimulus-driven BCI, and then translate that into useful commands to control an external device. So broadly, we could categorize BCIs into a self-paced BCI and a stimulus-based BCI. So on the left here, we see a self-paced BCI where it's driven by the user's intention. That, for example, here the user thinks of moving their leg, or in this case, a dorsiflexion, and then there's the BCI system that detects the dorsiflexion and then moves a pedal, an external controller in this case. And on the other side, we have a stimulus-based BCI, which is driven by an external stimulus. So here we see different types of stimuli on the screen, and based on which stimuli, in this case, it's a visual stimulus, and based on which stimulus you're looking at, certain responses in the brain could be captured and then used to transfer that to an external device, and then have this entire BCI system. So today, the talk will be about Ssvp Bci. So I have a short video here. I'm not sure if the video should. Okay, I'm just going to play the video, and Yeah. So this is actually one of the side projects that we had that uses the open BCI system here. So we see the open BCI, and we're using just 3 electrodes from the occipital cortex, O1, O2, and OZ. And on the screen, there are these 4 different flickering stimuli, and each one flickers at a different frequency. And the intention is, for example, if so the user looks at the flicker that's labeled 1 here, we detect that flicker and then translate that command to this robotic hand, and then it will show 1 as the digit. If he looks at 2, it will show 2. Looks at 3 fingers, 4 fingers. So let's see that. So it's looking at 1, 2, 3, and 4. So that's basically an Ssvp-based BCI system, and we'll be talking about some of the methods that were used actually to run this detection algorithm in real time. So what is an Ssvp BCI? So what we saw were these different flickering objects, and each object flickers at a different frequency. So let's say one of the objects was flickering at this frequency of 9.961 hertz, and the user was looking at that particular flicker. Then if we look at the FFT averaged over a number of trials of, let's say, one of the electrodes in the occipital cortex, then you would see a very prominent peak at 9.961 hertz and its harmonics. So in this case, the second harmonic. And this response is most prominently observed in the occipital and occipitoparietal area of the cortex. So these electrodes here. And by analyzing the dominant frequency, we would be able to decode which particular object the user was focusing on. So as part of the thesis, we explored some of these challenges and limitations of Ssvp-based BCI systems. So one of them being at the stimulus design level itself, where if we have stimuli that are closely placed, so closely placed stimuli, they compete for neural representations, and that effect is called the effect of competing stimuli. So that means, for example, here we see all these stimuli are very closely spaced. So if someone was looking at this stimulus, then the neighboring stimulus would interfere with that response. And so that would limit the performance of the Ssvp system. And so what we studied is the change in interstimulus distance and its influence on the performance of the BCI system. And it has been shown that the change in this interstimulus distance has a positive correlation with the overall performance. That means as you increase the distance, the performance improves. But having that kind of behavior actually limits the flexibility of the stimulus design for applications, as we see more and more, like these days people are moving from monitors to virtual reality or augmented reality based platforms. And so that was really one of the motivations. And so the objective here was to enhance the overall decoding performance and also improve the robustness under the influence of the competing stimuli. So as part of that, we investigated different BCI system design parameters, and all of these kind of influence the overall performance of Ssvp BCI. The first one being the EEG channel selection in the occipital cortex, the stimulus and interface design, and then the feature extraction and detection algorithms, they also influence the performance. And lastly, having the training methodology itself, that is having a user independent versus user dependent training. So we proposed 3 different studies and 2 different methods. The first 2 studies that I'll be talking about will cover the influence of the competing stimuli, and we explored 2 options there. The first one was a channel selection method, and the second one was to use novel detection algorithms. In this case, it was a convolutional neural network. And the third study was looking at the user independent versus user dependent training of the detection algorithms. So here's some more details into each influencing factor. So for the channels, we fixed this at 6 channels. The 6 different channels here are like O1, O2, OZ, PO3, PO4, POZ. And this was done for ease of setup. And we actually only used 3 among the 6. And so we proposed a user-specific channel selection method for that. In terms of the stimulus design, these are all the factors that would affect the performance. So for example, the stimulus frequency, the rate at which they flicker, the shape of the stimulus, the color, and also the interstimulus distances. So in this case, we fixed the frequencies, shape, and color, and then we varied the interstimulus distances. For the feature extraction and detection algorithms, so the baseline for Ssvp is now the canonical correlation analysis, and it's also somewhat an unsupervised method. So there is no training data required. So and that has been the baseline algorithm for Ssvp. And in this case, we also proposed another method based on convolutional neural networks, but the input to that would be transformed features. So in this case, FFT features will be input to the CNN, and we'll go into the details like further into the presentation. And then the last aspect is the user dependent versus independent training. So what we mean by that is for user independent BCI means we have data that we've collected from a group of users, unique users, individuals, and then we train a classifier, and then we hope that this classifier could generalize to a new unseen user. And then for the user dependent BCI, we have a classifier that was calibrated based on training data collected from one user. And at the time of testing, we used that single classifier for the same user. And if there's a new user, we retrain the classifier on that user's data. So now coming to the methods. Sorry. Yeah, so this was our EEG acquisition system. We used the G USB amp and the G Scarabeo wet electrode system. It has a sampling rate of 1200 hertz. And we used 6 channels. Reference was at FBZ and the ground was at right earlobe. And for the stimulus design, we made sure, so this was really from previous studies. So Ssvp, the responses are maximum when in this range of 8 to 16 hertz. They are prominently observed when you fix the flicker frequencies in that range. So we picked frequencies, 7 different frequencies in that range. And they were circular stimuli, and we wanted to have this high contrast black and white. So we designed a color to be black and white. And then the 3 different distances were 5.24, 8.5, and 12.3. So for the experimental protocol, we have one trial would look like this, where you have this yellow marker, and this is actually exactly the way OpenVibe has designed it. So we kind of modified a little bit of OpenVibe code to get these stimulus parameters. So I'll just play that. So at the beginning, what the participant will see is a yellow marker that will direct the attention of the subject. So in this case, look at this particular stimulus. And then there's a 6-second stimulation period. And then there's a break or a pause of 4 seconds before the next stimulus appears. And so the stimulus was randomized, the stimulus distances were randomized between participants. And yeah, so that was designed and developed using OpenVibe, and all the offline analysis was performed in MATLAB. Yeah, so here's a little bit about the pre-processing. So we use a 4th order Butterworth bandpass filter between 1 hertz and 40 hertz. And the data length was fixed at 3 seconds, from 0.5 seconds from the onset of the stimulus up to 3.5 seconds from the onset of the stimulus. And this was really for the channel selection method that I will be talking about. And for the other two methods, we have a different way of processing the data. So the first, like the baseline method, is called the canonical correlation analysis. And basically what we have multi-channel EEG, and then we have these reference signals, which are just sine and cosines of the different stimulus frequencies that have been used in the stimulus design. And so CCA performs a correlation between the reference signal and the EEG signal. And these are based on some kind of linear transformation. So maximize and find the WX and WY. And then you find the maximum correlation coefficient corresponding to the particular stimulus frequency. And that becomes really the class or the class of the given trial. So there is no training data required in this case, and it will just be knowing the stimulus frequencies as the priors. So in the first method, what we observed was when we applied CCA and we used certain channel combinations for each user, we found this. So earlier I mentioned about a positive correlation between change in the interstimulus distance to the performance. So we observed that if we chose certain channels, that actually reduces and the correlation, so there is less variation between the three different distances. So the way we kind of calculated that was we have these three different, so we have data from each of these distances for every participant, and then we apply CCA and compute the accuracy. And then we try this for all possible 3-channel combinations among the 6 different channels that we've used. So you will have 20 such combinations. And then we pick the top 20% of the channel set and choose the best 3-channel set, the one that had the least variation among the 3 different distances. So we compute the accuracy for each, and then we pick the one that's best for the one that has like this factor least among the 4 channel combinations. So when we did this for each user, we actually found very interesting results, and I'll come to that in the results section. The second approach that we use here is using the convolutional neural network.
Sorry, quick question on the design.
Sure.
Are you using a single frequency, or do you have 8 frequencies?
We have 7 different frequencies. Yes.
And are they just evenly spaced across up to 40 hertz, or whatever your upper limit was? How do you choose those?
They are not evenly spaced, but they are. So these are actually the 7 different frequencies. Right. And we choose them such that at least the second harmonic doesn't interfere with one of the other frequencies.
Yeah. Cool, thanks.
Yeah, sure. So the second approach was looking at a convolutional neural network based approach, and there has been a lot of interest recently in exploring deep learning algorithms for Ssvp classification. And the network, the architecture was inspired by this paper for our study, and we modified it just a little bit in terms of looking at the number of channels and the frequencies. And the input, so this firstly is a very shallow network. Usually we see networks of 3, 4, 5 convolutional layers, but it's a very shallow network of just 2 convolutional layers. And the input is not a time domain, but it's transformed, it's the frequency domain. And in this particular case for Ssvp, we see that the features are in the frequency domain. So that was really the motivation for providing the frequency transformed data as input to the CNN. There is also another paper that has looked at using the time domain, and they have also like shown very interesting results. So we do have some comparison at the end of the presentation, like towards the end, with that work as well. And so the way the data is processed to provide as input is, so we take the FFT at a fixed frequency resolution, and then we only look at the components between 3 Hertz and 35 Hertz. And the way the data is processed is, so we know that for training these kind of models, we need large amounts of data. So one way to augment the data is we looked at 1 second windows sliding at 100 milliseconds. So every 0.1 second shift, we have a 1 second window. And this is somewhat also known as asynchronous processing. So just a quick note there is we have synchronous and asynchronous processing. And so since we are talking about like visually evoked potentials, usually they are like windows are positioned from the onset of the stimulus. But in this case of an Ssvp Bci, we would want something where we don't really know the onset of the stimulus, but we just want to process a given window of a given window of EEG data. So that's really also the motivation to go for this asynchronous processing. So the previous approach explored looking at the magnitude spectrum feature. So what happens is for every window, we compute the magnitude spectrum of each channel, and we provide that as input to the CNN. Here, what we thought is we could also leverage like the phase information that the network could learn. And so we provided the real, so we extract the real and the imaginary part and just concatenate that into one feature vector and provide that as input. So this is referred to as the CCNN going forward. So looking at the architecture, the input is actually channels by frequency components. And the first convolution layer really just works in the channel domain. And that's really motivated by the spatial filtering analogy. And the second convolution layer works in the frequency components domain. So it works in the horizontal space. And then we have the final classification layer, the softmax layer, which corresponds to like the number of classes or the number of targets in the Ssvp. So in terms of choosing the hyperparameters, we used a grid search for the batch size, for the dropout ratio, the number of epochs, and the learning rate. And the weights were initialized based on a Gaussian distribution. And the final parameters were chosen like based on the ones that generally resulted in like best performance across all participants. So for the first case, when we explored the influence of the change in interstimulus distance, so the way we trained the CNN was we trained the CNN on the smallest distance and then tested that on the second and the third distances data. And then in case 2, we trained this on the second distance and then tested on the other 2. So it's somewhat leave 1 or leave 2 distance out sort of methodology. And really we wanted to investigate whether the CNN parameters learned on one stimulus distance can generalize to other stimulus distances. And this is really interesting because, for example, if we wanted to have this kind of Ssvp system that works in like a virtual reality environment, we could have one model that generalizes across stimulus distances. And let's say tomorrow you want to change the interstimulus distance by a software upgrade. You can just do that, and the parameters of the CNN can remain as it is. You don't have to retrain a new model.
I have a question. If you go back to the convolutional slide.
Yes.
Actually, maybe the slide before that. I'm just curious about what this distinction, or if there are distinctions between the MCNN and the CCNN, because like what I'm interpreting from the above chart is you basically take like a 3D tensor and then like the first convolution is like compressing it in one dimension, and the second convolution is compressing it in another dimension. Is that what MCNN and CCNN is referring to? Are those the layers?
So that's a good question. Sorry. So the MCNN and the CCNN are just names like given to the approach that would use the magnitude spectrum features like this as input, and the architecture remains the same. And the CCNN is just like the input has changed. So essentially it will be double the size. So in this case, we will have the real part and the imaginary part concatenated, and they will just be 2 times the length, and the architecture remains the same.
Wait, what's the imaginary part?
So from the FFT, we compute the real and the imaginary part. It's a complex.
Oh, okay, got it. Right. Okay,
Yeah.
cool. Thank you very much.
Sure. So now coming to the user-dependent versus user-independent approach, the model training was performed in this way, where so for the user-independent approach, we leave one subject out in the training and use that left-out subject for the validation. And for the user-dependent approach, we use a tenfold cross-validation within the data collected for that particular user. So we look at the results. The first study was the user-specific channel selection. And so what we are seeing here on the left is the average accuracy across the 3 different interstimulus distances. So S1, S2, and S3 are the 3 different distances. So we see already that when we use the 3-channel set, so in this case, what we refer to as 3-channel set is just the O1, O2, and OZ. And 6-channel means all 6 channels. And then we have a user-specific set of like whatever the user-specific calibration found. So we see that in the 3-channel set, as the distance increases, there's a sharp jump in the accuracy. And also for the, if we used all the 6 channels, there's an increase, like the positive correlation. And when we use the user-specific set, we do see that there is positive correlation, but I mean, it's not significant. And there is very little variation between the 3. And that's what we see on the right side here. So what we're seeing here in the yellow bar is the variation among these 3 bars. And then the blue bar is the variation and so on. So we see that there is significant reduction in the variation when using this user-specific set. So we could say something similar, that no matter which stimulus distance you choose, as long as we have the same user-specific channel set for that user, you would get very similar performance among the 3 distances. And now looking at comparing the results for the CNN, the MCNN, CCNN versus the CCA approach, we see that we see very similar response here. So S1, S2, and S3 are the 3 distances. And we see the best performing approach is actually when we provided both the real and imaginary part as concatenated feature vectors. So the CCNN approach really performs well. And we're seeing that even for the smallest distance, for a very short window length of 1 second, you can achieve very close to 85 or above 85% accuracy. And the same with S2 and S3. And these results are really based on that training methodology that we saw earlier. So we could use the same CNN architecture, and then it kind of generalizes to different distances. So these are the results from the third study. So here we are comparing the user-dependent and the user-independent training of the CNN. And so here we see we are also comparing this with 2 other approaches. So this actually has been published at the Journal of Neural Engineering. And So we looked at one approach that was FBCCA in addition to the other approaches compared earlier. FBCCA is filter bank canonical correlation analysis, and that's one of the unsupervised user-independent approach. And we also looked at the task-related component analysis, which is this state-of-the-art method for supervised Ssvp detection. And it was actually surprising. We'll get to that in a while. But among the different approaches, we see across the different windows and participants, among the user-independent methods, the CCNN provides around 81% accuracy for 1 second. And the user-dependent, the CCNN provides around 92.5% for 1 second. And generally, we see the user-dependent methods performing much better than user-independent, and this is expected. And on the right side here is the information transfer rate. And so we see that also in the user-dependent CCNN case to be higher than the other methods. So this actually was a 7-class Ssvp system and was on private data. And so we wanted to also compare and benchmark that result with a publicly available data set. And so we picked a data set that has a 12-class Ssvp, and this is by the Schwartz group. And they have also compared, there are multiple publications on using that data set. And so we thought we could use that data set also in terms of comparing these algorithms with the other published methods. And so looking at the accuracy on the left-hand side here, so we see very high performance again for the user-dependent approaches. And among the user-dependent approaches, the CCNN provides almost 92% accuracy. And among the user-independent methods, the CCNN also provides 81% accuracy. And so
another question, just
yes.
a clarifying question.
Sure.
When you say user independent and user dependent, are you referring to the train test splits being among participants and between participants, or are you referring to a pre-processing step where you filter things out?
It's the first case that you refer to. So it's among participants and between participants.
Follow-up question: How does that compare to the other pre-processing steps? So you did CCA and all these other things.
Yes.
Do those also have different train test splits, or are you only showing one half of them?
So for the that's a good question. CCA, FBCCA, these are considered somewhat user independent, and the TRCA is user dependent. So we picked what we see here, the first 4 methods are all comparing user independent methods, and then these 3 are user dependent methods. Did that answer your question?
That's really helpful. Thank you.
Okay, sure. Yeah.
Excuse me.
Yes.
I had a follow-up question on that.
Yeah.
In terms of user-dependent method, was overfitting an issue that you had to be mindful about, or was overfitting the goal? It was specific to a user.
Yeah, that's a good question. So we try to avoid overfitting by including batch normalization and dropout in the network itself. And so whatever results we are seeing here are actually the cross-validated results. And so and these are reported on the test set.
Okay, that sounds good. Thank you.
Okay.
Oh, one last question. Sorry.
Yeah, no problem.
No, I'm just curious. With the convolutions, was there a theoretical underpinning as to why you chose the convolutions that you did, or did you also do a hyperparameter sweep over different types of convolutional architectures?
Yeah, that's a good question. So we did not do any architecture search. So this was actually just based on a previously published paper using a very similar architecture. there's actually just a very small change. So this is actually the paper. And in this paper, they actually compare two different, so they have a shallow network like this, and then they compare it with another deep network, and also they compare it with just feed-forward neural network, like without convolution. And they found this particular architecture to provide one of the best results. So we just used that architecture in this work.
And I dropped a link to that article as well as yours in the chat.
Oh, excellent. Okay, great. Thank you. Yeah, so the next step for us was just to compare the results with previously published results on the public data set. So these are all the other methods. So for example, the combined TCCA, the compact CNN, the IETCC, and the combination method. So these were methods that use the same data set, and then they reported these results. So we see like among the user independent methods, the compact CNN and like the proposed user independent CCNN, they perform like very similar. And the compact CNN actually is a convolutional neural network, but takes the time domain data as input. So one advantage of the CCNN is when you already convert the data into frequency domain features, what we observed is there's a reduced number of training parameters, the reduced training time, and it's a simpler architecture, and we can achieve very similar performance with a smaller or a less complex architecture. And among the user-dependent methods, we see like the user-dependent CCNN performs very similar to the combination method. And the combination method and ITCCA are really extensions of CCA, but using individual templates that are unique to every user. Yeah, so the first analysis, that was the user-specific channel selection. So it showed that when we use these user-specific channels, it outperformed like the classical 3-channel set or 6-channel set, and also it was shown to be less variable against like the change of interstimulus distance. And also the proposed CCNN method, we enhanced the overall decoding performance under the influence of competing stimuli, and also like it provides that flexibility to change in interstimulus distances. And the last user dependent versus user independent was really to answer this question, like what is good? Should we go and collect huge amounts of data, or do we have very little data and we should just work with that? So we observed that there is a trade-off between like achieving high classification accuracy and like the cost of collecting calibration data. So like we see that the user-dependent methods, they offer good performance compared to like user-independent methods. But if we have like enough resources to like collect calibration data from multiple users for each individual user, then obviously user-dependent method provides the best performance. But if we only have limited resources and we could like offer to collect small amount of data, then you could go with the user-independent approach, which is like a good balance between performance and cost. And in terms of future work, I think there is some work that we could explore. For example, transfer learning based methods, where you could have this kind of user independent, like small amount of training data, but when there's a new user, you could explore like transfer learning and fine tuning the model. And another question here is, so how much should we collect? And so maybe there's some work there that we could explore in terms of like number of users required for good generalization across users. And also like trying the CNN based approaches in an online setting would be really useful. So now probably I could like talk about the video. So in the video, what we saw was a dry electrode system using Open BCI and Open Vibe, and the detection algorithm was actually using canonical correlation analysis, and so that performed quite well. But we don't know in terms of generalization and like how good robust it would be across users. So maybe that's one place to try like the CNN based approaches. Yeah. So
Okay.
with that, yeah, sure.
Sorry, I have so many questions.
Yes.
Have you explored using attention-based methods, like just because like these are waveforms, it seems it pattern matches very much to sound data, and there's quite a bit of research done there. Like, you know, Google made WaveNet, and that performs fairly well at and so there's like other unsupervised learning techniques as well. So I was just curious, like, what your thoughts are there.
Yeah, that's true. So we haven't explored that, but I think like there's definitely like we should like explore all the new methods, and yeah, there is some merit I think in terms of like exploring. There's a lot of interest, and we're seeing that like day by day we see a lot of publications using deep neural networks for EEG, and yeah, I think that should be something that we could explore in the future. Yeah.
Awesome, thank you.
Okay, and yeah, so with that, I'll conclude my presentation, and of course, I want to thank all the people who funded our research and our lab, and all the participants for taking part in this study. And yeah, thank you, and I really appreciate all of you, and like thank you, Morgan, for having me here and giving me the opportunity to present the work to all of you. And so, yeah, sure, you can contact me on my Waterloo email address, or I'm also available on Slack. You can also contact my supervisor, Professor Ning Zhang. He's the director of the Waterloo Engineering Bionics Lab. So there are like other research work that if you're interested in, you could contact him. Yeah, thank you.
Okay. Yeah. Thanks so much, Arvind. And as part of your presentation, you actually were giving us a great case for Moab.
Yes.
In the sense that, like, you talked about how you chose a particular data set because, one, it was publicly available, and two, people had reported particular techniques against that data set.
Yes.
So you know, without necessarily having their pipeline available, you could, by benchmarking against, the Schwartz Center data set, for instance, anybody who's reported results on that, you kind of get. Now, of course, the Moab argument would be you want to have that pipeline. You want to have all those pipelines
Yeah.
available, as well as all the publicly available data sets, and try and not only check what they got on their particular data set, but their technique against other data sets, as well as obviously a full table comparison.
Yes. Yeah. Absolutely. Yeah. Absolutely. So like we usually find like all these competitions in the computer vision domain, and they just could like directly compare their results with another published work. But in I guess in like the EEG or BCI domain, sometimes we would have to like re-implement the algorithm on our data set and then like show the results. But if we had some kind of leaderboard or some public data sets like this, then you could just make direct comparisons, and that would like really make it faster, I guess.
Right. Yeah. And so anyway, this is why I loved this discussion on Slack. Mavi's here. Is Sweta able to join us? I'm not sure. But anyway, you guys actually meeting from first meeting on Slack. Yeah, I mean, this is the thing, right? Is this was Alexander Berchand's argument when he started Moab for motor imagery, and so have you played with Moab at all?
No, not yet, but I'm looking forward to it. Yeah.
Sure. So I know. I mean, I haven't played with it since Sylvain. So Sylvain Chevalier, who's at I believe he's moved to Paris Saclay now. I think he's in Alex Granfor's lab, but was at University of Versailles and has been kind of maintaining Moab. Posted that he's added a couple, or he's in the process. I haven't actually checked the GitHub repo itself in terms of if that's up to date, or like if those new data sets are there. Sorry, I'm just checking. Let's see what the last pull is a little bit ago. Okay. Well, anyway, it's I know one of the data sets that he definitely has on the high priority list is the I mean, it's that Schwartz-Center data set. I forget the last authored name.
Masaki Nakanishi, I guess.
Yes. So, and I saw also, I mean, so Moab is built on, or uses M&E objects. So it's things that are already in M&E or available in scikit-learn are usually pretty easy to get added as pipelines in Moab. You haven't. I noticed you haven't checked. You haven't benchmarked against common spatial patterns.
No.
Okay.
Yeah.
And
yeah, we usually see like common spatial patterns for like 2-class problems on like motor imagery data sets. There are actually other methods, like they try the Riemannian approach, and for Ssvp, I felt that maybe it depends on the use case. Like even for example, I mentioned about the task-related component analysis, like that is the state-of-the-art method. But in this case, we think one of the reasons it performed poorly was because we pre-processed the data in like this asynchronous fashion. And it was not always tied to the onset of the stimulus. And maybe if we used segments from the onset of the stimulus, there's some phased information that probably is like useful. And we found that task-related component analysis does really well when you have that kind of like stimulus-locked trials. So it could be, and so it really depends on the use case.
Because I mean that particular, or that publicly available data set that you did benchmark against, their actual paper was like a comparison of CCA, CSP versus TRCA versus, right? I mean, am I remembering right?
Yeah. I think so.
Okay. But you think that, I mean, certainly again in Moab, like, Moab's definitely trying not to be a pre-processing tool, and but you think that there were some differences in terms of the pre-processing versus their analysis.
Yeah, so I think like the factor there would be the window length, and because if we look at a longer window for SSVP, all the methods would become kind of similar, and like the difference would slowly start becoming insignificant. So it's really in these like shorter windows that we would see high performance. We would want high performance, and that's also driven by the fact that we want this to be real time and have like high information transfer rate. So looking at shorter windows of like 1 second, and I think some of them even go lower, like less than 1 second.
Right. Sorry. I mean, I know. Yeah. I mean, it'd be awesome to get Ziping to actually talk.
Yeah.
And I mean, I'm seeing like 6 papers from him just this, just in like the last 6 months, all BCI, SSVP. Sorry, let me just. Well, so what are your Python dependencies for your? I mean, do you want to show us, or do you want to take us through what you've got on GitHub?
Sure. Yeah.
Not to. If other people please, or if you've got more questions or just ideas for I know we've got some students who are also listening in and interested in terms of what directions we could potentially go with this.
Yes, I have a question actually.
Yeah.
Arvind, thank you for the great presentation. I wanted to know if you would consider the task of detecting motor imagery oscillations similar to the task of detecting SSVPs, if there is any parallel in between those two.
Like in terms of the detection algorithms, or?
Yes, in terms of because both of them are oscillations, so would the detection algorithms would be totally different, or are they related?
Yeah, so I think they are a bit different. So there's also like the signal to noise ratio, and in terms of SSVP, we see the feature is very high. It has very high signal to noise ratio compared to motor imagery based systems, based signals, and also the channel locations are different. But in terms of the pre-processing, so we would get very easily with like frequency domain features for SSVP. Whereas for motor imagery, we would need to, it's not like on that single trial basis that we would immediately get the features like an ERD or ERS. So that's why like we go for complex pre-processing steps like using CSP or other types of averaging and like spatial filtering and more number of channels. Whereas
But
for SSVP, we get it with less than 3 channels. It's possible.
I see. Thank you.
Hi, I found it really interesting how little channels you used. So like motor imagery, I often see, around like 20, 30 channels being used.
Yes. Yeah.
So when you were selecting your channels and you were trying to reduce your variation, how did you know how much information you were taking out when you were trying to reduce your variation?
Yeah, that's a good question. So we kind of used the accuracy of the CCA to look at the variation, and was also tied to this kind of interstimulus distance aspect. Maybe a different approach could have been to look at some kind of correlation just between the features within the channels before applying any detection algorithm. I guess we went for the CCA approach.
Mm-hmm. Yeah, and also like the accuracy is quite amazing, in the 90s and 80s. With the motor imagery based systems that I've seen, they actually aren't as good. So they're more like 60s to 80s, are the ones that I've seen at least. Could this method be applied to frequency and time-based motor imagery features.
I see. So for the motor imagery, I think it's a slightly difficult problem compared to SSVP, and using time-based. I'm not sure if I understood that. What do you mean by
so like ERD, quantifying ERD and ERS, which is a time-based feature?
It's still, I mean, it's still a somewhat different problem. You know,
Somewhat different problem. Okay.
I mean, you know, like certainly, like, you know, the reason you can get away with 3 channels or even 1, right?
Yeah.
Is that you're looking for a particular frequency.
Yes.
And in this case, you know, you kind of know. I mean, it's a small patch of cortex. You know, when you work at Smith Kettlewell, they give you a little card that just has you know, V1 like flattened on the card, and they're like, this is what we work with, you know. And it's nice where it's located, as long as you can get good contact there. And yeah, you know, like, this is why it's such a powerful technique. I mean, it's so great, SNR, CNR, that, you know, you can get something in a really short amount of time.
Yes.
You know, and so, you know, like, I'm hoping we'll get to actually more complex things you can build on top of SSVPs, by you know, not just doing these kinds of flicker frequencies, but actually slotting in images, and doing rapid presentation of images. But again, still, like, you can get such nice signal in such a short amount of time that I think you'd really have to move to doing something like having, you know, a vibratory stimulus, to get like a somatosensory response, you know, or seeing some of the like Scott Kelso's group, where they have people doing motor actions, like rhythmic motor actions, so that yeah, it's not just like real, or, you know, I mean, it's kind of like this ongoing, you're setting up an oscillatory thing.
Yeah, like the difference is it's not an endogenously generated rhythm, right? So it's not like rhythmic brain activity in the sense you think of with resting state and with the natural intrinsic oscillatory properties of neurons and the nervous system. Like, you're injecting an oscillatory signal into the brain. So in a way, you know, obviously it's a visual response, but it's a bit unphysiological in that sense, and it's not necessarily a particularly naturalistic type of stimulus either. I know there probably weren't that many SSVP things knocking around on the savannah or whatever. So it's kind of unique in that way, in terms of it's not like real brain activity in a sense.
But I mean, it's a great point. I'm glad you mentioned it, though, because it's something, you know, it's a phenomenon we can exploit, right? And we've seen this with, you know, or certainly, you know, one of the reasons why it has such a long history. And I again super recommend, check the I think it's last week's Meetup agenda references, but Tony Norsha's, you know, kind of like review article of steady state VEPs, giving you like the very long history of them, you know, because they really do go back to like the 30s, and as well as, you know, Tony can say much more about like all the ways that it's been exploited by vision scientists over the decades, and you know, what I'm hoping we also get to is later is how you can do it in the auditory domain too, right? And certainly there was, you know, and yeah, anyway, it's a great point.
I have a general question, and actually, Morgan, could you post a link for that review article again, because that might be somewhere that addresses this. 'Cause it's not an ML thing. It's really just in terms of the original brain responses with the different frequencies. So the question is, with SSVPs in general, do you get better signal at certain frequencies? And do you know what that profile looks like?
Yes. Yeah. So there is a paper. So the range is between 8 to 16 hertz, the flicker frequencies in that range. And there is somewhat a band pass kind of a response. There is a paper they tried, I think, from 1 to 100 hertz of flicker frequencies. I'll try to find that and post that.
Yeah, I mean, I know that Tony's at least got something on that, because Justin Ailes, who's on this particular review paper, which I posted in the chat, Justin built an LED inside a ping pong ball. So he could completely, had total control over the stimulus, and they could just range through, a wide range. It's super relevant, especially when if you are interested in moving to complex stimuli, like these fast visual presentation streams, like the optimal frequencies are even lower. It's like down to it's like between 5 and 10 hertz, where they're it's like a stream of objects, and then like every sixth picture is a face or something, and yeah, like that optimal range shifts even lower, which for reasons I'm not fully understanding, this review might help. But yeah, I was curious about that when because these spellers, I mean, certainly Ziping's got us like a 40 class speller. And
Yes.
and by the way, like so Ziping Zheng, who's I think a co-director at Schwartz Center, has a bunch of papers this year and videos of the of the spellers, and this is research going on in Taiwan. So they're actually doing Chinese characters, and yeah. Anyway, I'll see if I can really quickly find any of the YouTube videos, but they exist, and yeah, they're very high multi-class.
So what I wonder from that is whether the reason why, because it sounds like, at least when you were saying this range around 8 to 16 hertz, I mean that's very alpha-y.
Yeah.
And in the brain, kind of in the brain, in terms of the brain that you see in EEG, it tends to hang around 6 hertz, 12 hertz, right? It kind of there's more signal there. So the two kind of thoughts that come to me are, A, is the reason why you get better signal in that range because you're benefiting from resonance effects with intrinsic brain oscillations, and it's not a mutually exclusive, or is it just more power in that range, full stop? So more signal just because of the 1/f structure of the EEG, and or the way the brain kind of is able to, the way that high frequency signals aren't really as visible in the EEG. They're not mutually exclusive. One of them is just signal, and the other is brain physiology.
I mean, I would love to this would be the other benefit of having multiple data sets and control the pipelines, but looking at the individual differences, right? And getting a sense of how much like getting FOOF plots on these subjects, and seeing like how much is this particular subject really having their alpha overlapping with ones that you are getting, you aren't getting, you know, et cetera. You know, and I'm sure, you know, some literature on that exists. But I'd love to see that, you know, and I also love to see eye tracking data too, you know, because obviously there's some assumption here in terms of, you know, how well a person can actually control how their you know, eyes are darting around.
Yeah, there's also like these are like interesting analysis. There's also when we go to higher frequencies, you don't really perceive the flicker. So maybe that's another factor that influences the performance.
Yeah, so I posted a link on there, a particular BCI. I don't think that's the. Sorry, let me. I think there's a better one. Sorry. Yeah, sorry. Here's the. There's the implementing over 100 command codes. So it's actually together with Jen, but yeah, I mean it's interesting to watch, and let's see what's the particular I'm trying to remember the name of the. I think it's called BEST, but it's like a Beijing. There's a Beijing BCI data set that is also like super high class number. I forget the. I think we talked a little bit about it, Arvind. I realize now that he has. I mean, Sylvain has that Beijing one in at least on his list.
Okay.
Like to be done, but I think I was thrown off because on the list he says like 35 subjects, whereas there are actually 70 subjects in that.
Oh, okay.
That one, and so I was confused if that, you know, if it was really referencing the same one, but yeah. So certainly what we're hoping to do is identify more publicly available, you know, Ssvp data sets, right? You know, so flesh out the number of data sets that we can benchmark against, right? So that's super important, and we'll in fact get, you know, although we can't, you know, design those experiments, that will give us, you know, there's a lot of variability between these.
Yes.
A lot of different class numbers, a lot of different, you know, screen setups, a lot of different designs, and they're collecting, you know, in some cases, you know, 64 channel, which they're calling high density. It's not. It's yeah. If it's not over 100, it's not high density. And well, okay.
What is it? Medium density?
Sure.
There's got to be a name for.
Sure. Yeah. You know, it's just hitting that. It's hitting that spatial Nyquist.
I'm calling it high density in my grants.
Okay.
I won't get in trouble for that.
But you know, like, you know, not everybody's just doing, you know, 3 or 6 channel stuff. Even though with Ssveps, you really can get away with it. You know, if those channels are well positioned, and certainly there's some discussion of and this is something I've actually seen, I think, in some of Zhiping Zhang's most recent papers, like I forget what he calls it. He calls it like no. Can you use no hair channels? So in other words, If not using direct occipital channels, but being out here where there isn't hair, can you still get a good enough, a good enough sense of visual cortex, at least in the frequency domain? So I thought that was funny because they're actually calling it like no hair channels. And,
so just a quick note on the benchmark for the 12 class problem, everybody used like all papers used all 8 channels in that data set.
Okay.
So even in the CNN approach, like we used all the 8 channels, but only with our data set, like the private data set, we were able to like choose certain channels. So there we used only 3 channels.
Sure. And and that's certainly something in Moab. It's mainly about setting up the paradigm. So it's like essentially having the pre-processing kind of done, and just how are you cutting it up, and how are you temporally segmenting it, and so you could still have some of your time windows and other dimensions on which you're looking. So it's paradigm, pipeline, and classifier, right? So or classification, and so you had some of the filter bank things, some of the you could have basically like your feature engineering and your particular classification, and as you see obviously in a lot of the EEG lab papers, there's even like hybrids of CCA plus CSP, for instance, or like you talked about the filter bank TRCA or so because there is a lot of overlap, right? Like Moab already has a number of these kind of baseline pipelines, because motor imagery does use some of the same techniques, right? So CCA, for instance, obviously CSP, at least in a for simple data sets, like Sylvain said, he wasn't quite sure what to do with the kind of like super multi-class SSVP data sets, but I'm just thinking about Mavi's presentation a couple weeks ago, just in terms of the things that so CCA, CSP, and minimum energy, right? I mean, those were at least talked about. Things that are all relatively easy to get from scikit-learn, if they're not already there in Moab. And so sorry, were you going to show us some of the?
Oh yes.
On GitHub? And,
yeah, so is this visible?
Yep.
Okay, perfect. Yeah, this was really just, we thought maybe like, personally, like I had the feeling that everything was in MATLAB, so maybe we could push some of this into Python and then just have a repo that's accessible. And we actually provide this link also in the journal manuscript. So this is the repo, and we just have like 3 notebooks. The first one is just an introduction. So in the notebooks, so it's an introduction to SSVP, just explaining based on this 12 class data set. So there is the link to the data set, and that's the paper.
Yep.
And in the notebook, we actually just go over the data set. So here we just load the data set, do some pre-processing, filter the data, get these segments, and then compute the magnitude spectrum just to to see what it looks like. So in this particular data set, it was interesting to see that subject 8 has very good response. So what we are seeing here are like the average of all the trials for stimulus frequency 9.25. And so all the 12 different stimulus frequencies. So I think the application was like a dial pad. And so these are the 12 different targets. And each target has that particular stimulus frequency, and they also modulate the phase. So they have a different phase of the flicker. So subject 8 had very good response, and in some of the cases, we will also see like a very good second harmonic. And then there was the other case where there's like noise and very poor performance on like one of the subjects, that was subject 2. So we just see that example as well here. So this is subject 2. So it could be really good. So this is where like we would try to maybe improve Ssvp Bci. Like in this case, probably even just CCA would do really well. But in cases like this, we would need like other detection algorithms where we would still want to improve the Ssvp performance for these kind of responses. So the second notebook is just implementing CCA.
When you're using the phase and you're combining multiple trials, do you need to be doing this in a time locked fashion? As in,
So
need to be time locked to some onset to be able to average a phase?
yes. So in the case of the detection algorithms, yes, they would use and also use that information in the templates. So in the case of CCA, you would also have a phase term and then use the phase term here.
Right. Because I think you said earlier that there was some cases where you were using stimulus onset timed data, and in some cases where you weren't.
Yes, that's correct. That? Yeah, so there's the synchronous way of pre-processing and then the asynchronous. So all the results that we showed were all like asynchronously processed.
So can you use the phase if you're not stimulus onset locked then, or is the asynchronous also stimulus onset locked?
Yeah, I'm not entirely sure. So if it is stimulus onset locked, we should be able to use the phase. If it is not, I haven't looked at what it would, like how it would change.
So, the data that they make available,
Yes.
is that already segmented?
Yes.
Is it raw data or?
Yeah, it is the raw data.
Okay.
And you have every epoch.
Okay.
So I think they have 15 trials. So you have the 15 trials for each stimulus frequency for 10 subjects.
Like it would also need to be it wouldn't just need to be stimulus onset locked. It would the stimulus would need to start at the right phase.
Right.
Yeah.
Yes.
Which wouldn't necessarily always expect. I don't know if you would. Yeah. Sounds tricky.
Yeah, the way this would have been implemented, I think like the stimulus design, I think that would have been implemented such that it would start at that phase.
Here's the they might be giving us more details here. I mean, Oh, okay. Well, so the onset of visual stimulation is at the 39th sample point. So that sounds like they've given us the, given it fixed to, a particular point, and then
Yes.
yeah.
Yeah. In fact, so I think when I load the data, I look at it from that sample number.
Okay. Yeah, go back here.
Yeah. So I am loading the data from particular sample.
I mean, these notebooks are certainly really, really nice and helpful.
Yeah. Thank you. Yeah. So the second one actually is just implementing the CCA, and then just looking at the results of CCA, and the third notebook is just looking at the user-dependent training part of the MCNN and the CCNN. So you can actually find like all the steps. So we load the data, and then so we perform the 10-fold split, and the CNN model is actually developed in Keras.
Okay.
So we just import the Keras, and then there's just one function. And so that's really the CNN architecture. And then we have two other functions. So the first one is computing the magnitude spectrum features for all the trials, for all the segments. And then the second one is just the complex spectrum features. And it's really that step where we have the real and imaginary part, and we just concatenate them. So that'll be the difference. And these were the hyperparameters that were set for the training. So there's the feature extraction step. We have the magnitude spectrum features, the complex spectrum features. Yeah, and then we just call this function. So that's for the MCNN, and then that's for the CCNN. And then finally, there's the summary of the results.
Yeah, I mean, it's so some of what you've got is not, or if someone was going to be bringing this into Moab, you're obviously recreating some of Moab's functionality.
Okay.
In a totally good and necessary way, right? I just mean that like bringing it in would, again, what's great is you've got this publicly available data set that we can have, and we we know what we should be getting with CCA and MCNN and CCNN, and certain by default. I mean, you can set this, but by default, I think Moab's using a 4 or 5 fold. But these are things that we could set appropriately, check, make sure we're getting these same results.
Yes.
And then basically make these same pipelines available. Make your 2 CNN pipelines available in Moab, along with CCA, which you're using, of course, using scikit-learn.
Yes.
And
it's from scikit-learn. Yeah.
Right. Yeah. And yeah, I mean, so part of this is like just trying to outline what I think would be, you know, a future direction in terms of merging this with you know, Moab, and what it would benefit in terms of, you know, being able to then not only benchmark against it, but also look at this across a whole bunch of data sets. Yeah, so I think somebody raised their hand. Ryan, you had a question? Or
Yep. Yeah. Sorry, since I have changed settings on the recording as well.
Okay.
Yeah, this was really interesting. Some of the, like, using, like, the hexagon pattern and running everything at different frequencies, it looks like that was somewhat what, like, Neurable was doing with their VR headset, or was it Neurable or whoever?
Next Mind was definitely doing a SSVP.
Yeah, but they only showed a minute of it, but the VR headset one,
Oh, okay.
which
Neurable or Lucid, yeah.
yeah, Neurable, I'm pretty sure, where they were using objects in VR, and it looks like they would, when you wanted to select something, it would bring them up in a pattern and then flash each one, and you'd select based on the flash. I don't know if they've said what algorithm they were using for their neural network or what accuracy they got, but this is definitely very interesting that it I didn't know so many of these different algorithms actually lined up after like a second and a half stimulation window. But I do think getting a accuracy at a lower window is important, because it, at least in like games and a lot of things where you want to work fast, 1 second is even a bit long for selecting something. Like, I know a lot of situations where people would want to select multiple things. Like, you showed that telephone number pad. If you had to do a 4 second stimulation window, it could take quite a while to write out a simple phone number.
Yes.
And if you made a mistake, you'd need to hover over the back button, which would have to go at its own frequency. So, like, did you guys think about trying to add a higher number of frequencies to check? Like, how many different visual frequency stimuli can you have on a screen at once, and how much does contrast affect it? Because, like, you said you use black and white, which makes it very easy to notice the difference, but I'm guessing in a lot of user applications for selecting things, it would not be black and white. So maybe, like, it sounds like there's future research you guys want to do
Yes.
with, like, mixed training methods of, like, user and group based training, to make it more accurate. And I'm definitely interested to see how this stuff evolves. Do you know, like, what you're thinking about testing out next? If you're going to try, like, using a similar data set, or expand on your testing to test for newer or different variables?
Yes, yeah, that's a very interesting point. So the first question I think you asked was regarding the number of targets. So we did not, like, so in our lab we did not try beyond 7 targets, but there are papers, for example, like Morgan also pointed out earlier, that they tried like 40 targets. And I think there are different stimulus approaches, not just the repetitive flicker, but there's also like motion onset VP, and so we could look at these other types of stimuli, and so that could be like the next step, not just looking at flicker, but looking at some other types of repetitive stimulus, and that could also elicit very similar responses to like Ssvp. And in terms of contrast, yeah, there is a lot of research that talks about change in contrast, the color of the stimulus. So I think red also provides very high, next to white, I think red provides good response, but I think it also has the risk of inducing seizures in some cases. They mentioned that red and blue light could induce seizures. So we kind of stuck to the black and white scenario. They also tried gray as a background. Yeah, so I guess there are like a lot of interesting avenues, like also like Morgan mentioned, in terms of using more naturalistic stimuli or using pictures. So that's something that could be explored because all of these are very simple. I know like there has been a couple of articles, I think they tried human faces and they try different human facial emotions, and that elicits different kind of SSVP responses.
Yeah.
So yeah, there's a lot of research yet to be done, things to explore.
Yeah, and one of the other kind of side benefits of going with faces as stimuli is that it actually moves the kind of like site of highest signal kind of away from the pole and more towards the ears. And basically, you know, with say something like a muse, it actually moves it a little closer to where Muse is actually collecting data as opposed to on the pole. So that's one of the cool, you know, that's one of the side benefits of going with these, you know, face area kind of specific signals. You know, again, like, okay, good night. Yeah, thank you so much for, you know, Mavi joining us. I know it's late.
Thank you.
Yeah, and yeah, we should let Arvind also get to bed since we still got a work day tomorrow. Yeah, I mean, I'm really trying to make a wide push on this. You know, to see this as like, you know, a great effort that could be, you know, we could be pooling across Neurotech X members, you know, literally worldwide. And because again, like this benchmark in particular, you know, this is a really great tool for other methods developers, right? It's like getting state of the art pipelines in, you know, and then benchmarking them against, you know, multiple data sets as opposed to, you know, one or two, potentially one of which is closed, you know. This really, there's really nothing better, you know, like in the sense that like we just don't have these kind of like massive image sets and things that you know the ML and DL communities are have gotten so used to, and even within subjects, you know, we don't have massive amounts of data. So yeah, I'm hoping we can have you come back and you know, you can yeah, I mean, I don't know what your day's like, but if you don't want to join so late at night, there's always the Paris meetup, which is basically noon noon East Coast, and you could be joining Paris in their evening. And yeah, and of course, and let's not forget that Neurotech X India is got a meetup on Sunday, which would be my morning, their evening.
Okay.
And yeah, so everybody can check that out on Slack. Hack Nights on Slack, Hack Nights channel, and yeah, thank you so much, Arvind.
Yeah, thank you so much. Thank you for having me here. Like it's also a great opportunity, like for me to share the work that we've done during the masters. And yeah, like I'm trying to be more active on Neurotech X. So even when I was a master student, I would come and I've attended like a couple of events, Kitchener Waterloo area, and
Cool.
trying to be more active. And yeah, I'll definitely like join. And it's also a great opportunity for me to like learn about the various developments. So it's been great. And thank you so much. And it's been really enjoyable like talking to all of you here.
Awesome. Well, you don't have to go, but I would totally understand if you do. And we will follow up for sure.
Sure.
So yeah.
Thank you.
Thank you.
Good night.
Night, Arvind. Yeah. Okay. So coming on 8:30. Yeah, I don't know if anybody has any topics that they would like to bring up in this last part of the evening.
I have a little thing from a bit of discussion last week. Is like, so new graphics cards are coming out, and I learned a bit more about the NVIDIA's new core, like CUDA core and Tensor core approach. Like their CUDA cores, they've doubled their CUDA cores, but it's not actually double the performance. It's whether it's like double precision or single precision and a couple other things. And I definitely think like if anyone in the community gets one of these cards early on, it would be great to have them try running one of these neural networks, if possible, have someone benchmark it on a old card and then a new one, just so we start to see whether it's worthwhile for any of our researchers to get a new card, if it actually makes a big jump in how fast it processes, or if it could even take some certain algorithms from being near real time to full real time analysis.
Well, I'd certainly love it if we had, like a TUH EEG benchmark that we used to and then could convince other people to benchmark it across multiple card instances, or even better, like a DX1 or DX2.
Yeah. I
So,
mean, we could have, if someone knows how to make a good benchmark, like, we could make one and just send it out, because let's see, there's like almost 20 people on this meeting or something, or 15, I think. And a lot of us have multiple computers, and we could just try it on a ton of our own computers. I mean, with the community being all pretty much 5,000 people, we could actually do a pretty robust benchmark of how hard is it to run different data sets, because that could very well influence researchers when they want to build a new computer, or build something for their testing, if it's has to be put in their budget.
Sure. Well, I mean, yeah, that would be great. And, or certainly if we could get more Ssvp data sets in, this would be a smaller benchmark that, or this could be a small one to test against. TUH is still pretty damn big. Although I would still, still hoping we can get Anders or someone to volunteer a pipeline that does train on TUH. But brain decodes, I don't know if they've actually released the TUH, but anyway, there's definitely some examples. Sorry, go ahead.
What's really exciting coming up with the tensor cores is that, they're really responsive to whether it's floating point 16 or int 8 or int 4. And some people are even doing int 1, where the entire neural network is just literally binary digits going on, and they scale really well. And so maybe even proactively being like, hey, how do we take our existing neural networks and then adapt them to be FP16 or int 8? And it's really cool, like,
sure,
how much it's exactly like 2x the performance just by sacrificing a little bit of precision.
Yeah. No, that would be cool. I mean, and well, sorry, Rashik, you had something?
You can go on. I had a separate question.
Oh, okay.
So,
I was just going to say, that also that particular kind of direction relates to what we've been talking about in Paris in terms of shifting down to kind of like edge processing and like very efficient, very small scale, but seeing what works. And again, like it being a real use case when you're talking about like sending people out into the real world with these Ssvp things. I mean, that certainly the original paper that the CNN was applied to was ambulatory EEG. Like, so this was people walking around. Anyway, sorry, Raj, go ahead with another question.
Yeah. So I was wondering, how good are the open BCI headsets when you're on the move, like when you're doing something like running or working out? I wanted to do some tests with the Muse, but it's not really suited for that at all. So
Yeah, I mean, well, do you have a Muse S?
Yeah. No, I don't have a Muse S. All right.
So I mean, Open BCI, unless you're going to move to a cap, that is definitely not what it was. One of the use cases they were thinking of. And what I can definitely recommend is the Moby Awards. So just looking at some of the Moby Awards papers, like best papers, and looking at what those particular research groups who are definitely trying, are like pushing the, like one's got like a person on a Stairmaster, so you're dealing with, you're dealing with sweating, you're dealing with moving, you're dealing with like all sorts of things, right? Yeah, I mean, the nice thing about the Muse S is that, it's definitely a bit tighter than a Muse because it's made for sleeping, right?
It's tighter, but I don't think I would be comfortable sweating in it. It is like $300, and I am not confident that I'll be able to clean it well.
I gotcha, but like sweating's a real, certainly a big thing when you're talking about, especially like getting a long recording, right? So this is something that this is certainly something that Kyle's looked at too. It's Kyle Matheson in Alberta. He's got a bike rig, and the Moby Lab are using like research EEG systems in backpacks, and then conventional caps, but a lot of it is also like post processing. A lot of
Okay.
how they're managing to take out the all the artifacts. And so again, I recommend I certainly recommend those Moby Awards as giving you some great example papers.
Sure, thanks.
Yeah. Yeah, I mean, it's like this is one of the reasons why Brandon, it's Brandon Marcus, the Dutch developer who worked on his own headset, was basically trying to get a better fitting OpenBCI headset. So I think that's definitely why they moved to the caps.
So I had another question, like more of giving an introduction to. It's the first time I happen to attend this event, and thank you so much for organizing this. It was pretty interesting to learn about what's going on at this point. And so I'm a recent Northeastern graduate. My name is Omkar, by the way. And I specialize in data science and HCI research. I don't have a background in neurotech, but that's what I aspire to get into. I wish to pursue a PhD at the intersection of how humans and machines interact with each other, and how could we create better ways to interact, right? And at this point, like I actually moved to the West Coast about a week ago, right? And it was a strange welcome for me with what's happening around, like with the heat wave, and later on the.
Yeah, are you in the Bay Area?
Yeah, I'm in Sunnyvale right now.
Okay. Yeah. I mean, for those who don't know, we entered a like movie scene. I mean, it was
Yeah,
really
Blade Runner 2049 weather, yeah,
it,
or Mars. Like,
yeah.
go online. There are videos of what SF looked like yesterday. It does not look like planet Earth. There was
I've
someone.
been for 2 days now.
Yeah, welcome to. This is generally not what the Bay Area normally looks like this time of year. Like
I
it
took
has
my daughter
been
to
the
school.
past couple
Yeah.
years.
Well, I took her to school at 8 a.m, and like I honestly was afraid I was going to get a ticket because I didn't have a bike light. Certainly all the cars are they got their headlights on and everything.
Yeah.
Like I just haven't needed a light because I don't ride at night. Just anyway.
Yeah.
It was so bad that it came down here.
Yeah.
Did it?
Not today, but yesterday we couldn't even see the sun. It was so smoggy from the fires.
Exactly.
Yeah.
Coming back to my question, my major area of like interest for research is how could we use neurotech to track and enhance cognition. All right. So I have been volunteering at one of the research labs back in Northeastern, where we are working on smart room technologies for group meetings. So, and our major focus there is identifying cognitive biases and like gender and cultural biases that hinder with team performance. How could we track and mitigate these biases? And our major interest there is through an approach and through non-invasive, unobtrusive technologies. So it's more of like overhead sensors, video cameras, and speakers of getting verbal, non-verbal data, all that. But like that's when I started getting very fascinated by cognition, perception, and like neuroscience just seemed like a very good way to go about it. So at this point, like I've been actively seeking full-time opportunities. One of the reasons why I moved to the West Coast, and I was just interested in knowing are there any good universities doing some research work around this area, or like companies for that matter working on technologies to enhance cognition?
Oh, to enhance. Mm.
Well, even like it could be very basic. I just want to get some relevant experience before getting into a PhD.
Sure.
It could be anywhere on the lines of creating technologies that are used to measure physiological processes, neural processes, and correlate to cognition to some extent.
Sure.
Anything along those lines. If you guys have anything in mind, I would love to know more about that.
Sure, sure. Well, certainly one of the things that we've talked about, and I believe it's in the Meetup. Sorry, let me just double check. Yeah. So and down at the 8:30 mark, just so happens, is certainly some links. There's some publicly available data that we talk about there in terms of this ERP core data set. That's kind of is very much tailored to cognitive neuroscience students.
Okay.
Yeah, I mean, I'll just say that Moab also is, which again is also linked there, and oh, sorry, no, I'm correct, right? So then at the 8 o'clock mark, you can see the links, but Moab, and just at the bottom there, the GitHub to Mohit's EEG data sets, which is like a massive GitHub list, text file of lots of other data sets.
Right.
So we can certainly recommend lots of publicly available data, or where to find them. And what I kind of have been pushing ERP Core for is just that there's a really nice set of scripts that have been applied to it.
Okay.
And you can see all the intermediary results of those scripts. You can, without having to, hopefully you don't have to use MATLAB, although all these particular scripts are currently in MATLAB. But I just linked the M&E Lab viewer, which gives, so you can look at that, you can see all the intermediary results, and M&E Lab is actually a great way to get into M&E, which is, kind of like the premier Python toolbox for electrophys, EEG, MEG data sets, and actually now NIRS data sets too. So that's infrared spectroscopy. And so there's file readers for at least one manufacturer, and the kind of pre-processing. But what you eventually want to get to is hopefully, these are the neural signals that are correlated with, tasks or emotions or et cetera. So there's I mean, we would kind of point you to learn.neurotechxcdu.com. I don't know if that, like hoping to do as Brian talked about in the beginning, there's kind of like a 2.0 effort on that. So that's why I'm kind of
interesting.
Yeah, but that's why I'm like currently kind of pointing at ERP Core in terms of ERP Core and then the resources for teaching. Like there's, it's basically a really high profile ERP lab that's put together an online course for all of this that I really highly recommend in terms of like, if you're coming in new, like it would be a good place to start.
Okay, that's great.
But if you're kind of like, what we've been pushing with Moab is really, Moab is kind of designed to be an ML benchmarking framework. So in other words, it's hopefully like a more kind of data science friendly introduction, in the sense that like you don't have to learn all the pre-processing and things like that. What you're really focused on in Moab is like, you know, what are the best kind of like, yeah, how can I across, you know, I'm looking across multiple data sets because that's the best way to really get a good sense of my algorithms in different contexts and different situations. And yeah, it's better place for maybe data scientists to get involved, in terms of you've got ideas for you know, how to do that better. That was kind of what Arvind was talking about today. So that might be another direction to go. And yeah, any other resources that we might recommend? Well, certainly, you know, you're on Slack.
Yeah, I did join in last week. So it was
Well, keep asking.
a friend from OpenBCI who suggested me to like get into this community. So that's what like motivated me to come here. She also guided me to the Slack channel. So,
Great.
yeah.
Great. Yeah. And you know, and if you are so interested, you know, you can get you know, pretty cheap consumer headsets, and and also
I look forward to that. It's just currently I am juggling between a couple of projects myself, but as I happen to get some time, I want to get some hands-on experience with like some of these technologies. I have a background in electronics engineering, so like I think I'll just get a hang of it quite soon, and I'm super fascinated with neuroscience. So I'd love to do something cool with it.
Awesome.
I work in a lab that does augmentations, like cognitive augmentations included, and we work primarily with differently abled and special needs people, because that's where, you know, you can get the most hands-on data and get the most impact. And so potentially looking into companies and labs working in that area might be a good place to get your hands on some actual problems.
Oh, all right. I'll definitely begin.
Yeah, for sure. So somewhat related to that, I mean, I was going to just go over some of the things that are coming up. The tomorrow, M Brain Train is doing a special webinar on like EEG and music. So let me just and Stefan Debner is one of the speakers on this. But there's a hackathon coming up in I think it's the 12th and the 13th. Does that sound right? It's IEEE Brain. Just one sec. Sorry. And certainly that particular group usually has that kind of assistive technology focus. But yeah, music in the brain roundtable. Why should we research the neural correlates of musical interaction? And let me.
Would you mind dropping a link for that?
Yeah, just a sec here.
Yeah, it sounds awesome.
It's a great. So hopefully that will. So I mean, yeah, it's like definitely is always worth catching Stefan. So Andrew Chang from McMaster, well, two people from McMaster, Laurel Trainer, and then Anna Zam.
Is this 4 p.m. their time?
Yeah, so it's gonna. I mean, it's like that means it's like.
Yeah, I have no idea what that is.
It's maybe for you. It's no. You're Pacific, right?
Yeah, I'm the same as you.
Yeah, it's early.
Yeah. What is that?
Anyway, I would get up for Stefan, and I don't know if everybody saw that the Sigrid paper that that just came out. I posted it, I think, in the research channel in Slack, but he's doing a comparison of Sigrids and higher density systems, at least simulation study. Yeah. So that's not.
Oh, it's not 7 a.m.
Is it 7?
Yeah. It's not bad.
So GTech, or it's what's that particular it's like hack spelt with a 4. Do you remember what that's?
Is it Brain 4 Hack?
Yeah. Am I not finding that? Where would it be right now? Because is it? It must be in Lin's. It must be in Lin's. Isn't that where they're doing the?
Do you mean where they're hosting it from?
Yeah.
It says it's in Belgrade.
Oh, and no, this is the second.
Oh, okay.
This is the hackathon that's Sorry, let me just check IEEE Brain. I didn't have the links. I put them down. I've got other things this weekend, so I didn't actually sign up. Anyway, I will look for it, and I can post it in the Hack Night Slack channel. And yeah, so next week we've got as Brian said, Mohit Patil, who's the Connectome coordinator, is going to join us and talk about his experience at IEEE Brain Summer School that was just in August, and the project that they worked on, as well as we got Joseph Crew coming. So he was, he's a biomedical engineer, did his PhD down at USC, and then worked at Advanced Bionics. Is going to talk to us, do a presentation on cochlear implants. And his actual focus on cochlear implants was actually improving your ability to hear music, specifically hear music. But really excited because he can talk about, the engineering behind like probably one of the most successful brain implants that that is currently available, alongside of, I guess, probably like deep brain stimulators for Parkinson's. Oh, did you find it? Oh, great. Yeah, I think so. Or that, yes, because it's 12th and 13th. So thank you. Thank you, Amy. Yeah, yeah, I was totally spelling that wrong. But that's
They have the weirdest spelling. I would never have guessed that brain can be spelled with a 4 and a 1.
Yeah. I think there's still time to sign up for this. There's another thing that starts Yeah, I'll keep posting in the Hack Night channel. The week after, who we got? We got Pedal Tech coming to talk about their API. Again, you can check the Meetup agenda. Computational psychiatry course in Zurich was this week. Hopefully we'll see stuff posted when the week is over. So next week we'll see stuff posted from their up-to-date materials. Yeah. Anything else coming this next week? I know there's definitely more stuff because let me just very quickly check. Oh, what's up, girl? And well, GTech's been doing some webinars. Oh yeah, Neurotech is doing a webinar on the 15th that's covering gamma stimulation in Alzheimer's. That looks really awesome. You know, Alex was. I mean, I forget what his Slack username was, but Alex was asking about gamma stimulation and a particular company that Ed Boyden's involved with. What was it called? Anyway, it seems somewhat similar in terms of you know, can gamma range TES, you know, be therapeutic or potentially even cognitive enhancing. So somewhat relevant. Neuroelectrics is like neuroelectrics.com webinars. And oh yeah, well then yeah, there's an organoids webinar on the 17th, and GTech's has been covering their stroke recovery and Mind Beagle, which is their kind of like coma locked in detection. Hopefully those things some of these webinars will actually appear on YouTube. You know, offline, you don't have to catch them live, but things like the M Brain Train, I'm not sure if we'll see that, you know, see videos posted of that. And yeah. So on that note, or did anybody see the discussion of depression, closed loop TES, and depression that was on Slack? I was wondering, I don't know, John, if you had any thoughts.
I saw the discussion. Could you summarize where it went? I wasn't sure if it was a discussion that was kind of one of those. Does anyone know if you can do this? And then,
well, it started that way.
Lets them down that we don't know that much.
Yeah, I know. Or whether like how effective TES ever is. But yeah, I mean, I think I got across the fact that like there's no depressive episodes that you would necessarily like wait for and then stimulate, you know, in a kind of closed loop, like somewhat like a seizure detection stimulation closed loop. But you know, I pointed out.
Oh, because they were asking about closed loop.
Yeah,
right.
yeah. and the one thing that I found that I maybe I'll post in that particular thread, but I was curious about other people's opinions was so from that same group, Brain Clinics in the Netherlands, Martin Arns has been doing this vagal stimulation, vagal frontal stimulation. So he's like, if I can target this particular frontal area, then I can optimize it so that I'm getting a heart rate variability change. So if I can do it so that I can increase heart rate variability, the thought being that is somehow an endpoint to vagal nerve, and thereby getting all the benefits, like, and then doing that, you get all the benefits of a kind of like a non-invasive vagal nerve stimulation.
With TS, with frontal TS.
I think they were doing it with TMS.
Okay.
So I will.
I was curious to think about vagal nerve stimulation as being the thing you're aiming to achieve. Because that's like the most, kind of poorly understood mechanism of therapy of the whole lot.
Right. So no, totally. This is, I mean, so this somewhat related to just, I dropped a paper from them. And as far as I can see, that they're the only groups that, it's a little like the slow wave sleep, TES, closed loop TES. Like it's like all that slow wave sleep TES stuff is pretty much coming out of one group in Arizona. And anyway, this is, but if we remember the Eni, who presented last week with the vagal nerve stimulator, an implant, right? Like you can get some, like super impressive results in terms of what that vagal nerve stimulation did in terms of post-stroke recovery, right? There's definitely, as we saw, somewhat, like when I forget the CEO of Think who came to talk about their patch. Jade, you remember what those patches are called? Zing? Is it the Zing? Yeah.
Yeah, Zing.
Right. And anyway, I mean, after seeing the seeing Eni's results, or certainly, Kilgard Lab Texas results in terms of post-stroke recovery, it would be really nice if you could do some sort of vagal nerve stimulation without an implant. Okay, I think my family time is rapidly approaching, and so yeah, I'd love other people's opinions on this. I mean, I think Martin Arns is tremendous, great research coming out of there, and I certainly like this idea of a target that has a physiological response. Like getting a heart rate variability change is a real thing, right? Like I don't know how well, like how much you've got to do that, or like, and again, like, wouldn't it be easier to just try and stimulate from the nerve itself? But
yeah, definitely sounds like a lot of new studies people want to do. Like the other day I was thinking about like using TES or TMS for people in a coma, or like stuff like that, which like after reading a couple things on people like trying to now do TES and TMS while people are asleep and stuff like that, like, can it go farther? Because like I know coma patient EG and stuff like that starting to get a bit more substantial, and whether TES or TMS can make any physiological changes that could signal different things, or possibly even just help with recovery, like try to get a person to be using their own body rather than if they need a assistive system. But like I have a friend who ended up in a medically induced coma a while back, and they came out, but the whole idea of like research that needs to be done around it is something I talked about with them, and it's generally a section of research that, like, non-invasive research for coma patients is definitely, I think, something that's going to be needed in the near future.
Well, there's certainly some great stuff. You know, like I mentioned, Brendan Allison does a great talk on all the work that he's been involved with. Obviously, Adrian Owens. Just one thing. And what is it? It's like Beyond the Gray Zone, or anyway, Adrian Owens.
Into the Gray Zone.
Into the Gray
That's like
Zone.
one of the best books, science books I've read in ages, actually.
Awesome. Well, I will say the Why We Sleep, the Walker book is a really, it's a super valuable review of a whole bunch of research that, like, I'm absolutely, I mean, it played into my response on that depression question for sure, but like, yeah, he's got so much more in terms of just like, get sleep. Get sleep, don't die. Super important health stuff. But yeah, Into the Gray Zone is a great way to catch up with all their work at where is he now? He's at Windsor, Western. Yeah. And anyway, I want to thank our videographers, Ryan and Alex, and everybody for joining us. Please continue the conversation on Slack. And as always, if you've got things that you want to talk about, we can put it on the agenda, or we can talk about making a conversation around that. Always looking for ideas. And yeah, till then, see you next week. Bye, everyone.
Thank you.
Guys.